All right, so let's start with problem number 1. Write a rule for the nth term of the geometric sequence. And I think we got a formula for that last time. Let's see, let's write that formula again. AN for a geometric sequence is the A1 times R to the n minus 1. Okay, so the A1, the first number in my list, I don't have. The R, the common ratio, I don't have that either. All I have are the second number in the list and the fifth number in the list. So as far as making my list goes, I don't know the first. Second number is 12. Third, fourth. The fifth number is a negative 768, and so on. So this is pretty much all I have so far. I think I'm going to find the ratio first. So this common ratio is what I multiply by every time. So I should take 12, multiply by the R once, multiply by the R twice. I would have to multiply by that R 3 times to get the negative 768. So let's do a little formula here. 12 times whatever that ratio is. So I'd have to multiply that ratio 3 different times to get the negative 768. Okay, so I have a single variable. Let's go solve for the R. I'm going to divide by 12 on both sides. Let's see. Negative 768 divided by a positive 12. I'm going to end up with a negative 64. And then I'm going to get rid of my cubed exponent with a cube root. Just like you get rid of squared exponents with square roots. Cube root for my cubed exponent. Okay, so those are inverses. They're gone. I'm left with my R equals whatever the cube root of 64 is, negative 64, excuse me, whatever that is. So let's see, I got a negative 4. All right, I can't do a square root of a negative. That would give me like an error in the calculator, a non-real number. But your cube root of a negative, that worked out fine for a negative 4. That's not my final answer. They told me to write a rule. My answer should be a formula, essentially, a rule with the R and the A1, which I don't have the A1 yet. But since I know what I multiply by every time to go forward, I can do the opposite. I can divide by R to go backwards and get my next number here. So 12 divided by a negative 4 is a negative 3. So it looks like negative 3 is my first number in the list. So I'm going to put a little division here, divide by R to go backwards. All right, so now I think I have the 2 pieces of information I need for my rule, for my formula. AN equals the A1, which we just found is negative 3, times your ratio raised to the n minus 1. The ratio is a negative 4. Okay, so here's our rule, our formula. All right, let's try it again on part B. They gave me the second number in my list again. So my second number is 12 again. Third number, I don't know. The fourth number I know is a 3 though. The fact that I see this going down, like it was decreasing from 12 down to a 3, I'm probably going to have something between 0 and 1, like a half, a third, even if it's like 2/5 or something between 0 and 1 is probably making things decrease. So I'm going to do the same thing here. I don't know what the A1 is as of right now, so I'm going to go find the ratio first. I had to multiply by the ratio once, multiply by the ratio twice to get that 3. So starting out with a 12, 12 times whatever that ratio is, I had to multiply it twice to get 3. So I don't know what that R is. Let's go solve for it. I'm going to divide the 12 over, and 3 divided by 12, you could put it as the fraction 1/4, or you can do the decimal 0.25, same thing. And I'm going to get rid of my squared exponent by doing a square root. All right, and then square root of 1 is 1, square root of 4 is 2. So it looks like I've got a 1/2. Let's see if this works. 12 times a half, like half 12 is 6. Okay, 6 times a half, half 6 is the 3. Okay, this is looking good. Multiplying by that ratio is going to get me the next number, next number. If I want to go backwards though, I have to do the opposite. I have to divide by that ratio. So 12 divided by 1/2 is 24. So my first number in my list here is 24. Now I can write my little formula. AN equals the first number 24 times my ratio 1/2 raised to the n minus 1. Okay, so there's my formula. This was basically off the formula we learned before. Now you're going to look at a new formula for the sum of the finite geometric sequence. Sum we did on arithmetic sequences. We're going to do the sum for geometric sequences. So here's your formula. I still need the A1 and I need the R, which means in this case the A1 is a 4 and the R that was raised to the K minus 1, the R is a 3. Now in the formula they had like an I minus 1 with a little I under your sigma. These are K's now, but that's fine. They're still doing the same thing. It started at 1. Make sure that they start in the same place that the formula did. I don't care what the variable is, but the initial number that they plugged in was a 1 on both of these, so that's good. That totally matches. And then my n, we haven't messed with n yet. The n is where they're going to end their list, and in my case 10 is the n here. Okay, so those are the pieces I need for this formula. This will be the sum. Like if I add up all the numbers in my list, it would give me whatever this sum is. In my case, I've got the 4 times 1 minus r to the n over 1 minus r. So there are my r's, my n is 10. Okay. This could get kind of messy, especially like 3 to the 10th is pretty huge. I would probably leave that alone for a sec. I do know 1 minus 3 is a -2. I also know that 4 divided by -2 is -2. Okay, so let's see if I can put this part in my calculator. -2 times 1 minus 3 to the 10th. All right, this is huge. 118,096. Okay, so there's my sum. Especially because it's so huge, I probably didn't want to make my list of 10 numbers and then add them all up. I think using the formula was quicker. So I'm going to do the same thing on the next example here. I'm going to find the 3 pieces I need. I need the A1, I need the ratio R, and I need the N up here. I still want to check a few things though. I want to check and make sure that, like this formula does, start at 1. And in this case, it's a T instead of an I, whatever, it starts at 1. That's good. I also want to check the exponent, I minus 1. In this case, it's a T minus 1. But yeah, it looks like it matches. The rest of the formula matches. So that means I'm going to go ahead and plug in my A1, in our case, -16, times 1 minus R to the N, R being 0.5. and my n being a 7. Okay, so again, 1 minus 0.5 is a 0.5, and I've got -16 divided by 0.5, so pretty much doubling it for a -32. My 7th exponent there. All right, I'll probably plug this into my calculator. -32 times 1 minus 0.5 to the 7th. All right, I got -31.75. That would be my sum. Okay, now there is a last problem here that says there's a hint. Make it fit the formula. I told you the stuff I circled in black here, it wasn't part of my formula necessarily, but like I didn't use the I over here on the other side, but I still want to make sure it fits, which this one doesn't. That one starts at 0 and the formula starts at 1, so it doesn't totally match. And then the exponent is off as well. The exponent in the formula says I minus 1. This one says just I. So let's mess with this for a sec. If I make my list, like if I plug in 0, 6 times negative 2 to the 0. I've got plus 6 times negative 2 to the first, 6 times negative 2 to the second, all the way up to where I end at the 5. So it would look something like this. Okay. So I think our formula didn't have an I exponent, it had I minus 1 in the formula. So this exponent, I think I would treat as like a 1 minus 1. This exponent is like a 2 minus 1. If I need to subtract from the exponent every time, I need to have my I minus 1. But that's, like I said, this is a 1 minus 1. Like I start by plugging in a 1. So I got to change this starting at 0. I start by plugging in a 1 so that my 1 minus 1 is the 0. Okay, so let me see if this works on everything. When I plug in my 1, 1 minus 1 is 0. Okay, check. Plug in a 2. 2 minus 1 gives me this 1. Okay, plug in a 3. 3 minus 1 gives me the 2. 4 minus 1, 5 minus 1. That means I end at 6 minus 1. So I think this top number up here where I end has to be a 6. I end with a 6 minus 1. All right, so I think it would give me the same list. Check it out, but I should get the same list here all added up. And then that now fits the formula up here. I can do the 3 pieces I need, the N, the A1, and the R. So I can put that into the formula now. Minus numerator and denominator. The R in our case is a 2 raised to the N, so to the 6th. Okay. Let's see, I know that 1 minus 2 is negative 1. So 6 divided by negative 1 is a negative 6. Minus 2 to the 6th. So let's see. In my calculator, negative 6 times 1 minus 2 to the 6th. That ended up with a positive 378. Okay. All right, just make it fit the formula. All right, there we go.